Hello friends, I welcome you in lecture number 5 on Laplace Transform. In this lecture we will derive this formula for Laplace Transform of t raised to n, which is gamma n plus 1 divided by s to the power n plus 1, and this formula is valid for all values of n which are greater than -1. So before going for derivation of this formula, we just recall the definition of gamma function which we study in mathematics 1 course. So we know that if n is a positive real number, then gamma function of n is denoted by this notation and is defined by improper integral from 0 to infinity of the function e raised to minus x times x raised to n minus 1 integral is with respect to x. So this is the definition of gamma function which we will require here. Gamma n equal to integral of e raised to minus x x raised to n minus 1 with respect to x from 0 to infinity, and we will require this property of gamma function. We know that gamma n plus 1 is given by n times gamma n, and if n is positive integer, gamma n plus 1 is given by n factorial. This is if n is a natural number or positive integer, and this is valid for any positive real number. So with this in mind, we try to derive the formula for Laplace transform of t raised to n. So we start by the definition. By definition of Laplace transform, we can write Laplace transform of t raised to n equal to integral 0 to infinity e raised to minus st times t raised to n dt. We know the definition of Laplace transform. Laplace transform of function f of t is defined using improper integral of e raised to minus st times f of t dt, and here instead of f of t we have t raised to n, so here we replace f of t by t raised to n. Now we try to convert this improper integral in terms of gamma function, because our answer is in terms of gamma function. We want to prove that Laplace transform of t raised to n is gamma n plus 1 divided by s raised to n plus 1, and for that we recall the definition of gamma function. It is integral 0 to infinity e raised to minus x x raised to n minus 1 dx. Now here coefficient of x is -1, and if we compare these two integrals, we can have the idea that we have to consider the substitution s into t equal to x. If we compare these two improper integrals on the right hand sides, we have the idea that if we take s into t equal to x, then we can convert this integral on the right hand side in terms of gamma function. So I consider this change of variable. I change my variable from t to new variable x. Here variable of integration is t, and we are changing this variable to new variable x by this substitution s into t equal to x, and therefore we can write t equal to x divided by s, and provided s is non-zero, here we assume that s is a positive real number, any positive real variable. S is also a variable, but we are considering integration with respect to t, so during that integration we are going to consider s as a constant. So therefore we write t equal to x divided by s. So we will replace t by x divided by s, and we will write s into t equal to x, and we have to find out dt also. So we differentiate this t with respect to x, and we have dt by dx equal to 1 by s, and the derivative of x is 1. Here we are considering s as a constant, therefore 1 by s is constant, derivative of x is 1. Therefore dt will be replaced by 1 by s times dx. And we have to decide the limits of new variable x also. So here limits of original variable t are from 0 to infinity. So we can see that when t is 0, and we have taken s as positive real number, and when t is 0, we will have x equal to s into 0, that is 0. Similarly, when t will approach infinity, here if t approaches infinity, and because s is positive, x will also approach infinity. Therefore limits of new variable x are also from 0 to infinity. So now everything is in terms of x, therefore our right hand side will be converted in terms of new variable x. Limits of x are from 0 to infinity. We will replace s into t by x, t will be replaced by x by s, and dt will be replaced by 1 by s dx. So using all these things, now we write Laplace transform of t raised to n equal to integral from 0 to infinity e raised to minus s into t, that we have taken as x, s into t, this we replace by x. Instead of t we write x by s. So here we write x divided by s to the power n, and dt is replaced by 1 by s dx. Now we simplify this. This is 0 to infinity e raised to minus x, x raised to n divided by s raised to n into 1 by s dx. Now here s raised to n into s will be s raised to n plus 1, and it is independent of x, so we can write it outside integral 1 divided by s raised to n plus 1 integral from 0 to infinity e raised to minus x, and we can write this n as x raised to n plus 1 minus 1 dx. And now if we use the definition of gamma function, we can see that this integral is nothing but gamma function of n plus 1, and we are using the definition of gamma n. If we have gamma n, then we have integral from 0 to infinity e raised to minus x, x raised to n minus 1 dx. So you can compare these two. E raised to minus x is there, x raised to n plus 1 minus 1. So if we have n, we write gamma n, and instead of n we have n plus 1, so this is gamma n plus 1. Therefore Laplace transform of t raised to n becomes gamma n plus 1 divided by s raised to n plus 1, and we know that gamma n is defined if n is positive. Instead of gamma n we have gamma n plus 1, therefore gamma n plus 1 is defined if n plus 1 is positive, or we can say that if n is greater than minus 1. So this formula is valid if n is bigger than minus 1. If n is bigger than minus 1, n plus 1 will be greater than 0 or positive, and therefore gamma n plus 1 is defined. So this is very important formula. We will remember this. Laplace transform of t raised to n is given by gamma n plus 1 divided by s raised to n plus 1. Now we know that if this n is natural number, then gamma n plus 1 is n factorial. So if n is a positive integer or if n is a natural number, we will replace gamma n plus 1 by n factorial. So this is particular case. If n is positive integer or if n is a natural number, gamma n plus 1 is n factorial. So using this property of Laplace gamma function, we can write that if we have power as natural number, then Laplace transform of t raised to n can be written as n factorial divided by s raised to n plus 1. So this is the formula of Laplace transform of t raised to n which we have derived, and we will always remember this formula, very helpful formula in upcoming lectures. Laplace transform of t raised to n is given by gamma n plus 1 divided by s raised to n plus 1. This is valid for any real number which is bigger than minus 1, and in particular if n is a natural number or n is a positive real number, it is n factorial divided by s raised to n plus 1. So we will always remember this formula. Using this formula we can write down Laplace transform of t. Suppose we want to write down Laplace transform of function t, then we can compare n will be equal to 1 and it is natural number, so we will use this formula for n equal to 1, and we have 1 factorial divided by s raised to 1 plus 1. 1 factorial is 1, so we have 1 divided by s square. Therefore Laplace transform of t is 1 divided by s square. So this also we can remember, or we can derive it from this formula for n equal to 1. Similarly, if we take n equal to 2, we will obtain Laplace transform of 2 square. So we use this formula for n equal to 2, and we have 2 factorial divided by s raised to 3. 2 factorial divided by s raised to 2 plus 1. 2 factorial is 2 divided by s cube. Therefore Laplace transform of t square is equal to 2 divided by s to the power 3. So in this way we can derive the Laplace transform of this type of power function. Suppose I am interested in the Laplace transform of square root of t. Then here power of t is 1/2. So I will use this formula using n equal to 1/2. So I will take n equal to 1/2 here, and I will have gamma 1 by 2 plus 1 divided by s raised to 1 by 2 plus 1. So using that formula we have gamma n plus 1, n is 1 by 2 plus 1 divided by s raised to 1 by 2 plus 1. Now this denominator we can rewrite as s raised to 1 by 2 plus 1, that is 3 by 2, and for gamma 1 by 2 plus 1 we can use this formula. Gamma n plus 1 is n into gamma n. So using this formula for n equal to 1/2, we can write gamma 1 by 2 plus 1 as 1 by 2 times gamma 1 by 2, and we know that gamma 1 by 2 has value square root of pi. So we use that value here, and we will have Laplace transform of square root of t, 2s raised to 3 by 2. Therefore Laplace transform of square root of t equal to square root of pi divided by 2 times s raised to 3 by 2. So in this way we can use this formula to obtain Laplace transform of this type of powers of t. and we will remember this formula always. Laplace transform of t raised to n is gamma n plus 1 divided by s raised to n plus 1. This is valid for every every real number which is bigger than minus 1, and in particular if n is a positive integer or if n is a natural number, we will use Laplace transform of t raised to n equal to n factorial divided by s raised to n plus 1. So in this lecture we have derived this formula, and we are just using the definition of gamma function. First we write down the Laplace transform of t raised to n using the definition of Laplace transform. Instead of f of t, we take t raised to n, and then we try to convert this integral in terms of gamma function. For that we use this substitution s into t equal to x, and we are having everything converted in terms of x, and we use definition of gamma function here, and we are able to derive this formula. So this is very easy proof. Sometimes they can ask you to derive this type of formulas for Laplace transform. So this is all about this session. I hope you like it. Thank you very much.